exam review. Question number 31 starts off with, if $3,500, I'd love to have that amount right now, is invested in an account that pays interest compounded continuously, how long will it take to grow to $10,500 at 9%? Round your answer to the nearest 10. Okay. In order to do this problem, we have to remember, what is the formula for compounded continuously? If I can go into my memory bank, I believe it's A equals P-E raised to the RT power. Q stands for the present amount, which is 3,500. So we'll write 3,500 times E raised to the rate written as a decimal, so 0.09 T. So we don't know how long. That's what we want to figure out. And this is all going to be equal to $10,500. So we plugged in everything that we know, so let's go forward. Let's divide by 3,500. I think it's going to give us a 3, but I don't have to think. I have my handy dandy calculator right here to the side to show me what it's going to be. So let's find out. So 10,500 divided by 3,500 will give us 3. Told you. So this is 1, this becomes 3. So now we have 3 equals E raised to the 0.09T. Now in order to get rid of this E function, the only thing we have to do is apply a natural log to both sides of our equation. The ln of E is always and forever equal to 1, because the ln represents the log base E, so the log base E of E is 1, because E to the 1 power equals 1. All that good stuff. So we're going to add a log to both sides of this equation, so it's going to be the ln of 3 is equal to the ln of E to the 0.90, or the 0.09T. According to our power rule with logarithms, we can bring this 0.09 right to the front. So we'll come down here, and that's going to give us the ln of 3 is equal to 0.09T. And as I've already told you, the ln of E is 1, so there's no need to even write it down. It's just 1. So now we just divide by 0.09. And that'll tell us how long it takes for this amount of money to grow to $10,500. So the ln of 3, close your parenthesis, divided by 0.09. It's going to take it 12.2 years. I might start saving a little bit if I were you, if that was my money. But that's how long it's going to take, 12.2 years. Happy saving. All right, using the properties of logarithms, let's rewrite this logarithm if possible. So I want you to remember how we deal with multiplication, division, and powers of logarithms. And that's how we're going to expand. I'm going to write this answer in blue so it doesn't contradict with this answer here. So first of all, let's sort of deal with this top portion that we have. You've got the log base 13 of 11. And since it's being multiplied by the square root of m, we say plus the log base 13, because anytime terms are multiplied with exponents, you know, when you're multiplying a squared times a cubed, you would add the 2 and the 3 together to get a to the 5th. So that's the idea here, because a log is an exponent. So log base 13 of 11 plus log base 13 of the square root of m, which I'm going to write as m to the 1/2 power, because we don't like to have radicals in our logarithm expressions most of the time. All right, and then we're dividing by this n, so we're just going to say minus, because that's what you do when you divide. But you know how quotients work. X to the 3rd divided by x to the 2nd. You subtract the 3 and the 2. Log base 13 of n. We're almost done here, except this little power. We're going to bring it right out to the front. And here we go. Log base 13, because we love for our first log to have a coefficient of 1 most of the time. 11 plus 1/2 log base 13 of m. Minus log base 13 of n. Now, with all of this wonderful work that we put in, sometimes we can simplify. Like if this were log base 13 of 13, we could say the answer was 1, but At this point, we just stop because there's nothing else to be simplified. We've got variables, additions, subtractions, and nothing else can be expanded. And that's all she wrote.